Welcome to the Deep Dive.
Great to be here.
Today, we're diving into something that feels like it's moving incredibly fast. AI agents.
Definitely. It's shifting from, maybe a future idea to something very present.
Yeah, and it really builds on everything we've seen in AI, doesn't it? Classic machine learning, right up to the big language models we use all the time.
That's right. Like the next step in that evolution.
So to help us unpack this, we're looking at a specific source today. It's an article by Victor Loon called What Are AI Agents? How They Work, and Why They're the Future of Artificial Intelligence. It's from Continuous Improvement.
Yeah, it's a really useful piece. It does a good job of clarifying what we actually mean by agents.
Exactly. So our mission, really, is to explore Loon's take in this article. What are AI agents, fundamentally? Why does he argue they're so important? He even uses the phrase the future. Really.
It does. It's a bold claim.
And, where do they slot into this whole AI picture?
Well, Loon starts off with a pretty big idea, actually. He frames it in terms of human history and tool-making.
Oh, yeah. How so?
He basically says, look, humans have always built tools from fire onwards to extend what we can do. And now, with AI, we're building something, something more than just a tool. Yeah. He says, and this is a quote, "We are now building something more powerful than any tool before. Intelligent agents that can act, reason, adapt, and learn."
Wow. Okay. Act, reason, adapt, and learn.
Yeah.
That's a lot more than just processing information.
Precisely. That quote immediately signals that this isn't just about, say, a slightly smarter language model. It's proposing a different kind of system.
A system with what? Autonomy? Agency?
Yeah, some form of it. Not just thinking, but doing, and doing it with a degree of independence.
Okay, so how do we get to this point? The article traces a path, right?
Yeah.
From earlier AI.
It does. It talks about AI evolving, almost like mirroring human cognitive steps, starting basic.
Right, like pattern recognition in early machine learning.
Exactly. Then moving on to the big language models, the LLMs, which got really good at understanding and generating language.
Ones writing emails, answering our questions.
Those ones. And then the article notes, AI pushed towards more generalist capabilities, better reasoning, better planning.
Because we built these amazing brains, these systems that could understand, generate, plan, internally at least.
Right. But Loon points out a gap that remained, even with those powerful models.
What was missing?
Real, continuous interaction with the world around them. Their memory was often short-term, just the current chat. And they didn't really work towards a goal on their own, not without constant prompting.
So they were powerful thinkers, but sort of passive until asked.
Exactly. And that's where AI agents, as Loon describes them, come in at something new.
So what's his core definition then? How does he define an agent?
Okay, the key idea is this. An AI agent combines that reasoning power, often from an LLM, with the ability to perceive, plan, act, and learn. And crucially, it does this in a continuous loop.
That loop, perceive, plan, act, learn, in a loop. That feels really central. That's the differentiator.
Absolutely. It's the core difference. It means the system isn't just, doing one thing and stopping. It's constantly interacting with its environment.
How so?
It's observing, making decisions, taking actions, and then this is key, observing the results of those actions to figure out what to do next. All driven by some overall goal it's been given.
Okay, that makes sense. He uses an analogy in the article to explain this, doesn't he?
He does, the brain and body one. It's quite effective.
Right, so if an LLM is like the brain?
Yeah, capable of thought, language, all that complex stuff. Then the agent is the brain plus a body. It has senses, it has limbs, metaphorically speaking.
So it can think, and it can actually do things, interact, change things.
Exactly, to achieve its goal.
Okay, so let's break down how this brain and body system actually works. The article mentions 3 core parts.
That's right. 3 essential components. First up, you need the model.
The brain part.
Yep. The underlying intelligence. Often an LLM, like Gemini or Gemma, the article mentions, it does the reasoning, the understanding, the planning.
Got it. Intelligence engine. Component number 1. What's 2?
Second, you need tools. These are the agent's way of interacting with the world. It's limbs and senses.
Okay, like what kind of tools?
Well, things like giving it access to a search engine to get current info.
Okay.
Or APIs so it can talk to other software, maybe access to databases to pull specific data.
Okay, so the model thinks. The tools let it see and act in the world.
You got it. And the third piece is the orchestration layer.
Nervous system.
Good analogy, yeah. It connects everything and manages that continuous loop we talked about.
So it takes observations from the tools.
Feeds them to the model for planning.
The model decides on an action.
The orchestrator tells the tools to execute that action.
And then it observes the results, starting the loop again.
Precisely. That orchestration layer manages the whole cycle, observing, thinking, deciding, acting, keeping the agent focused on its goal.
That's what gives it that continuous drive, that autonomy.
Exactly. And the article points out there are frameworks emerging to help build this stuff. Things like ADK, Crew AI, LangGraph.
Tools to build the tools, essentially.
Sort of. They're like software toolkits to help manage the agent state, its memory, how the loop executes, makes building these complex systems a bit easier.
Okay, model, tools, orchestration. Makes sense. But why bother with all this complexity?
Yeah.
The article asks this too, right? If the models are so powerful, why do we need the whole agent setup?
Good question. Because, as Ling explains, even the best standalone models usually just do one task at a time. They work off their training data, which is static. They do what he calls single-shot inferences.
Meaning they can't just decide to go browse the web for the latest news or interact with your calendar app or remember context across, say, 10 steps of a project.
Exactly. They're like that brilliant consultant you mentioned, great answer to one question, but they can't then go and actually implement a multi-stage plan based on that answer. Agents are designed to overcome exactly those limits. They use tools to get current info. They manage context over long interactions. They connect to real-world functions through APIs. And they execute complex plans step by step towards a goal.
So the big shift is combining the thinking part with action and ongoing adaptation.
That's the core insight, yeah. Which brings us to that kitchen metaphor Long uses. It really clarifies the difference.
The chef. Right, walk us through that again. How does the chef map to an agent?
Okay, so imagine a chef. The customer's order. That's the agent's goal.
Okay.
The chef checking the pantry, seeing what ingredients are there, that's perceiving the environment, using tools like eyes and memory.
Right.
Planning the meal in their head, that's the model's thinking and planning.
Mm-hmm.
Cooking step by step, using knives, pans, the stove, that's the chef acting with tools.
That makes sense.
And crucially, tasting the sauce, adjusting the seasoning, that's learning and adapting during the process based on feedback. It's the loop in action.
Yeah, that really captures it. Gathering info, planning, acting with tools, getting feedback, adjusting, all to fulfill the order, the goal.
It makes that abstract perceive, plan, act, learn loop much more concrete.
Definitely. So, given these capabilities, where does Lung suggest agents are actually useful today in the real world?
Well, he points to areas needing complex, multi-step problem solving. Situations where you need to interact with systems that change, where information is dynamic. Adaptability is key.
Can you give some examples the article mentions?
Sure. Things like helping automate parts of scientific research, maybe analyzing financial markets by pulling data from different places in real time.
Okay.
Or handling really complex customer service queries that involve multiple steps, or looking up different bits of information.
Right, not just simple Q&A.
Exactly. Also, personalizing education based on how a student is actually interacting, or dynamic wellness coaching, even just automating tedious office workflows, like extracting data from emails and putting it into a report, which might involve multiple software interactions.
So basically anything that's not just a single response, but requires steps, interaction, persistence towards completing something.
That's a good way to put it. But Lung is also careful to say agents aren't the answer for everything.
Where are they not a good fit, according to the article?
He suggests avoiding them for really high-risk situations where you need absolute, predictable, deterministic results every single time. No room for error or unexpected behavior.
Okay, that makes sense. What else?
And also for simpler stuff. If a basic rule-based system or a standard machine learning model can do the job perfectly well, like following a strict flowchart or doing a simple calculation, then using an agent is just adding unnecessary complexity and cost.
Right. Don't use a sledgehammer to crack a nut. Use the right tool for the job.
Precisely. The article also gets into the practical side, the challenges of actually building and deploying these things.
Yeah, it's not push-button easy, I imagine. What are some hurdles?
Well, cost is one. Managing the cost of using the underlying model, the token usage, can be significant.
Yeah.
Because the agent is thinking and acting continuously in that loop.
Ah, right, token usage. Can you quickly explain what that means for listeners who might not know in the agent context?
Sure. So the agent uses that powerful LLM, the brain, for its reasoning. Every time it processes information, plans, generates internal text as part of its loop, it consumes tokens, which is how usage of these models is often measured and priced.
So more thinking, more acting in the loop.
means more tokens used, which translates to higher operational costs. So you need to be mindful of that.
Got it. The cost of the brain constantly working. What other deployment challenges does Lung highlight?
Designing and maintaining all the tools the agent needs, the APIs, the connections to databases, search, etc. That's a big job in itself.
Keeping the limbs and senses working reliably.
Exactly. And ensuring secure communication between the agent and all those external systems is vital.
And what about figuring out if they're even working well? Evaluation seems tricky.
Oh, absolutely. How do you measure success when the task is complex, maybe open-ended, and the environment is unpredictable? It's much harder than evaluating a simple classification model. The article also mentions transparency, needing to understand why an agent made certain choices. You need tools for observability, for tracing its steps.
So you can debug it or trust its decisions.
Right. And then just the practical challenges of managing potentially many autonomous systems running at scale, plus the security implications when these things can take actions in the real world.
Serious considerations. Ling also makes a point that agent isn't one single thing, right? It's more of a spectrum.
Yes, exactly. He talks about a range. On one end, you have fully autonomous agents, you give them a goal, and they just run with it.
Okay.
On the other end, you might have human-in-the-loop agents. The agent does a lot, but a human steps in to approve critical decisions or actions before they happen.
So the level of autonomy can be adjusted.
Yeah, depending on the task's risk and complexity. It's not all or nothing.
Okay, so pulling all this together from the article, the main takeaway seems to be summed up in that question he poses. To agent or not to agent.
Right. And his answer seems pretty clear.
Which is?
That if your task, your workflow, involves dealing with unpredictable information, making complex decisions, following sequential steps where adapting along the way is valuable, then agents aren't just theory anymore.
They're here now.
They're here now, according to Lung. They offer capabilities that go beyond what standard models can do for those specific kinds of problems, despite the challenges.
So we're really seeing this shift, moving beyond just building smarter models that answer things, towards systems that can think but also act and learn from acting, all aimed at a goal.
It definitely feels like a major step in AI's evolution, going back to that initial quote about tools extending our reach.
Yeah. Okay, so let's quickly recap the core ideas from our dive into Victor Lung's article.
Sounds good.
AI agents, as he lays them out, combine that LLM reasoning power with the ability to perceive, plan, act, and learn continuously in a loop towards a specific goal.
And they work using three main parts: the model or brain, the tools for sensing and acting, and the orchestration layer managing that whole perceive, plan, act, learn cycle.
We had that great kitchen analogy, the chef fulfilling that order, illustrating how they gather info, plan, use tools, and adapt based on feedback.
And Lung's view is clear. While there are real challenges in deployment cost, tools, security, evaluation agents are ready now for complex, dynamic tasks that need adaptability. They overcome the limits of simpler models for those specific use cases.
Which brings us right back to that powerful starting point. If we're now building systems that don't just think, but can act autonomously and improve themselves based on their actions, what does that really open up?
What are the limits of what they could achieve within their environments?
Exactly. What new possibilities, maybe even new questions, does this raise for you, the listener? Something to think about.